I was in the dorms, I freaking lived off those.
I've never gotten food poisoning off of those, so.
Off of a
Totino's.
shitty Totino's. Cool, good stuff. So no questions on the homework at this point. Okay, that's cool. And maybe I think that what we're gonna talk about today will help with a lot of it. And then maybe I'll go through and talk about each one. Let me go through the homework assignment and look at it. So one of them was find the inverse of, one of them wasn't in the book, right? So find the formula for the inverse of general Mobius transformation. That's one of the problems. Let me talk about that just a little bit. So find T inverse if T is our classic bilinear transformation. And what I suggest you do here is to set up Z equals T of W and then solve for W. This is going to take some algebra. And it's not hard algebra, but like, you know, it'll take a little time and thought. But then, so like when does an inverse exist? What are the conditions to have an inverse function? What are the things you need?
For the domain, it has to be one-to-one.
And onto. Yeah?
Yes.
What does onto mean?
One-to-one, like every element maps to exactly one, and onto is like every element gets mapped?
Two. Yeah, exactly. So one-to-one means that this doesn't happen. You've got two things getting sent to the same place. This is not one-to-one. So the conditions, how do you test for one-to-one? Let me actually say what I just said here. So if x and y are not equal, then t of x is not equal to t of y. That's one formulation of one-to-one. What's the contrapositive of that statement?
If x equals y, then tx equals t.
Really close, that's the converse. So here I've got...
Oh, sorry, if tx equals ty.
There you go.
Yeah.
Yes. So, yes sir, absolutely. So the first thing Nathan said was, if this is P and Q, the first thing Nathan said was not P implies not Q, which is the converse, but it's not the contrapositive. The contrapositive is not Q implies not P, and that's logically equivalent. These are the same statement, if you recall from logic and proof. So in other words, if the outputs are the same, just like Nathan said, then the inputs are the same. This is the way to show something is one-to-one. Because like, this is just hard. Inequalities, like how the hell do you even work with an inequality? But what you can do here is you can start with t of z, so assume, and you're gonna wanna do this for a very good reason. Assume this and show that that means z equals w. So you're gonna, you're gonna do this, and then you're gonna show that that means z has to equal w. But there is a condition that shows up along the way. This will happen provided, and then there'll be some condition on the coefficients. You'll find that in this. You will not see that condition when you do this, when you find the inverse. So I implore thee, show it's 1 to 1. Doing this is actually showing it's onto, because I'm showing how to hit any z. I'm going to come up with a formula for the w that hits any z. So in the process of finding the inverse, you will also show it is onto. So this question here, when does an inverse exist? Here's how you'll find. And the condition, and I want you to like think about matrices while you do this. Just think, if you had a matrix A, B, C, D, when does the inverse exist?
When the determinant is non-zero.
Determinant is non-zero. If the determinant is non-zero, what is the determinant of that matrix? AD minus BC is not equal to 0. Just saying, that might show up somewhere. There's an intimate relationship between these things in matrices, which is kind of interesting. So that's my tip on that. Let me go through number 3.9, take a look at that. Poor Sydney. I would have brought some for you if I'd known you were going to be here today. I don't know.
I didn't expect to be a functioning member of society any time this week, but I figured I should show the class.
You're doing, yeah, good on you. Proud of you.
What is Defy Kingdoms?
Oh, DeFi Kingdoms is a gamified crypto world. It's an RPG,
That's what I thought.
takes place in crypto realms, and it's
Lots
still
of
being
crypto.
built. What's
Let's
this?
don't get him started.
What's crypto?
Yeah.
God, that's a long question.
Are we talking about cryptocurrency or something else?
I'm talking about cryptocurrency.
I'm even more confused now.
So it's just like they have this token that they created, several tokens they created, and they have a game universe. A lot like the game you play, what's it called, Harvest Moon? So very Harvest Moon-y kind of game, but like you can actually make money off of it. So that's the thing, I told you guys, I hatched that pet that I sold for like $700.
Oh yeah.
Yeah, that's this.
Oh.
Yeah.
Wow.
Yeah.
You were looking at
Yeah.
What's this?
You were looking at 3.9.
Yes, I was looking at 3.9. So in 3.9, let's take a look at that. Is that the one where f sub a of z is z minus a? Please tell me. I actually didn't. Can I look? I better look at
Get
Noah's version of the book. In other words, the correct version of the book. Does anybody have a hard? Oh, Lou's got a hard copy of the new edition. What does 3.9 look like for you? Perfect. That's the one I want. So in 3.9, you're given this very special Mobius transformation, which is f of a of z equals z minus a over 1 minus a conjugate z. Show this as a Mobius transformation. That's literally showing it can be written like this. There isn't a whole lot to do for part A. There's not much to do for part A, just say it. Part B is find the inverse. So show that f sub a inverse of z equals blah. Well, guess what? You're going to find the inverse formula here. So once you find this inverse formula, you will be able to answer that question. So definitely find the formula for the inverse first. Look, you can look this up online and check yourself. This is not like secret knowledge. But it's good for you to go through it, right? That we build the power by doing, not just copying. And then prove that it maps the unit disk to itself in a bijective manner. So show that FA of the unit disk equals the unit disk. Let's talk about that after you think about it a little This might be like the hardest problem in the whole thing, so if you get stuck on it, don't worry. We'll talk about it, but it is pretty hard. And then 3.9, 317 is the next one. Oh man. Has anybody done any work on 317 yet? Scratch it. Take it out. It's too much. You'll get the same thing from part C here, and I feel like that's gonna become unwieldy, especially if we want to have a take-home exam next week. So let's knock 317 off the list. Yeah, you're gonna be super happy with that. And then, or you would be if you knew about it. 321 is cake in some ways. Yep. Just think about that. It's not cake, but it's not terrible. And then 336, just part A. Yo, absolutely. That is wonderful. And 338. Oh yes. Beautiful. All those things are good. So I think taking that 317 out is going to make life so much better for you. It's going to be way more manageable. If you want to do it, I'm happy to talk about it with you, because some people just want to do stuff. Alrighty, friends, let's finish up talking about functions. So here's a quick test yourself. What's the definition of this? E to the z is defined as what? Just write it down. And then write two forms of it. Write a couple versions of it.
Oh. Give me a minute.
And of course, we need to assume this. Yeah?
Absolutely.
Wish I had like a warm blanket to just give you or something, a little swat you could just pull around your shoulders.
I wish that I was sleeping.
Yes, I'm so proud. I'm like, I just want you to know, like
I appreciate it.
bold and powerful move. And you don't have to think too hard about this, right? It's literally like exponent properties. Once we do this, we can, look, we've got a real part and an imaginary part. How do I show this function? This is an entire function. How would I show that? Show e to the z is entire. How? How do we show things are differentiable? We want to show it's differentiable in the whole plane. What do we use to show things are differentiable? Cauchy-Riemann. So when you have to show something's differentiable, we're going to use the Cauchy-Riemann equations. What do those say? Can somebody besides Lou tell me? Let me get a chair. Oh yeah, Lavina, you would be great to tell me this. Why? Is that, are you reading the equation to me? Why?
Hold on, let me get my notes out. Maybe I have to use them. Okay. So e of y has to be equal to negative e of x.
Yep. There we go. That's them.
Yeah.
Indeed. Yes. Yes, yes. So if f is this and this, then f is differentiable where star is true. And entire means differentiable everywhere. So, can you please do this? Can you just demonstrate this? This is the kind of thing I'm going to have on the take-home exam, for sure. Having you check this stuff out, so let's just do it now. Demonstrate. Kind of done some of the work for you here. Right? There's you. Here's the B. So we just have to take those partials there, right? Luckily, one's an e to the x, so that makes life easy, because that's just good old, these are all real derivatives. We're linking the Cauchy-Riemann rings, real partial derivatives, to complex differentiability. So we just have to see that these things are equal, and these things are opposite equal, right? So equal, I don't know how it's hard to kind of write that there, so I'll just write it as a separate thing. But this one has a negative on it, this one doesn't, otherwise they're the same. So we've got Cauchy-Riemann completely satisfied no matter what u and v are, or x and y are. So it is entire. So this is true for all x and y. Cool. All right, so this is a lovely differentiable function. What's the derivative? Can I have a formula for the derivative? So d dz of, and I can use the uv form. Remember, when we have this, if this is true, then the derivative with respect to z of f of z, what was one formula for it?
U of x plus I u.
Yep. So you could just take the x derivatives of both the u and v parts. And that makes life easy. What was the other formula?
Is that u or v?
Oh,
That's probably a u of y minus I v of y.
no.
What's
U of x. U y.
IV of x minus IV of x?
I think so these actually mimic the Cauchy, this is where the Cauchy-Riemann equation came from,
Yeah.
right? So we did it along the x-axis, and we got this formula, and then we did it along the imaginary axis, and we got this formula.
So true.
So true, right? And look, it's the Cauchy-Riemann. The real parts are equal, and the imaginary parts are opposite equal. So that's how I remember these formulas. If you can remember one, Cauchy-Riemann your way to the other. So let's just go through and find this derivative. It's going to be the derivative of the u part with respect to x. Oh boy. Plus the x derivative of the v part. Oh boy. None of that's hard because they're just y things. That's the same function. So life is just the same as it's always been. The derivative of e is the derivative is e. Yes.
Can you do the extended form of e as well? Like the 1 plus, so is e to the z still equal to 1 plus z plus z over 2 z squared over 2 factorial?
As a power series? Yes.
Okay.
Yes. And then if you take that derivative, you see that it, yes, absolutely. The problem with that, a little bit, Noah, is just because, so in this case it's true, but just because we have a power series doesn't mean that thing is differentiable. It can be very tricky, because it's an infinite thing, and once we have infinite things, problems can arise. So I can create a function that's not analytic, but has a power series. It's a little weird. Okay, is this good? We feel okay about this? Let's see, what else do I want to say? Oh yeah, let's talk about the inverse of this. What do you think, what is the inverse of exponential function? What's the inverse? So if f of z equals e to the z, what do we usually call f inverse of z? What's the name?
Natural log?
Natural log, yes. Yeah, so let's look at complex natural log now. Complex natural log. So in other words, what we want to do is we want to solve e to the w equals z for w. So let's go through this. Now, w is going to be a real part plus an imaginary part. So I'm just using a little sub r, sub I, times I. Let me know what you think of this notation. I just thought of this the other day when I was like out doing math in the backyard. I was like, maybe I should just use r's and i's for the like subscripts instead of 1s and 2s. What do you think? Yeah? Is it confusing in any way? No? It's kind of nice because then it's immediate what that part is. So this is going to equal this. So I want to write this in kind of a similar form. So this is the modulus of z times e I to the argument of z, n argument of z. Right? Remember, this function here has infinitely many values. They're all the same angle, but there's multiples of 2 pi that kick in there. So let's rewrite this. This is e to the real part, e to the imaginary part equals this. And remember how these work. This is the direction. This e to the I part tells you where you're pointing. This is literally, this is on the unit circle, this is on the unit circle, and it tells me what direction. The thing in front is the modulus that tells me how far to go in that direction. So the moduli must be equal. If this is true, this says that e to the wr equals mod z. So they have the same modulus. And they also have the same argument. So e to the wi I equals e to the I arg z. And so that means, let's actually go one more. Let's take this. So now these two, what's WR? How do I solve this equation? This is just a real number stuff, as long as z is not 0.
Natural log of modulus.
Beautiful. Natural log modulus of z. So that's just, yeah, that's just like old school pre-calc. And then here, we've got wi has to equal the arg of z, and well, let's add on some plus 2 pi k stuff in here just to be safe. K is an integer. now we have a formula for the natural log, because the natural log is this thing. It's the exponent, the natural log of z is the exponent I have to raise e to get z. So, if that's probably a painful thing to hear, I've said it so many times that it doesn't bother me, but it might not be great on the ears and the brain. So, exclamation point. The solution to e to the w equals z is w equals natural log of the modulus of z, that's the real part, plus I times the arg of z plus 2 pi k. So there's actually infinitely many solutions here to this thing. That's just the basic natural log. Notice that the basic natural log, so we can define this is the natural log of z. It's the definition of it in the complex plane. If there's no imaginary part, it's the same thing, essentially, except that you get some 2 pi k's added on here. So let's do a couple examples. For example, solve e to the w equals 1 plus I. So w equals the complex natural log of 1 plus I.
Do we have special notation for complex natural log?
We don't.
We should get that.
We should get that, yeah. What would you suggest? Oh, what, CLN? Yeah, I was thinking that too, like CLN, yeah. The problem is, though, with that, Noah, it's, well, I guess it's not, yeah, there's no problem. Good idea. But let's just remember we're in complex analysis. And it will always be complex. And it will never be the complex log anywhere else, ever. So if we keep those guidelines, we'll be safe. So can you do this for me, please? Can you find that? What is the natural log of 1 plus I? Complex natural log of 1 plus I. There's your formula, right here. The lovely bell tone.
Sorry, I'm just getting home.
Oh. No sorries needed. It's okay. It was a lovely tone. Look like this is the modulus, okay, the square root of 2. What's an argument? Give me just one. Pi over 4. This is the principal argument, in fact. Remember the principal argument's the one that's between pi and negative pi. So here, this is literally the principal argument. Always a good first place to go. And to get that, of course, you just put 1 plus I, draw it out, and figure what that angle is. And it's a perfect 45. So that's nice. And I wouldn't ask you this unless it was a pretty thing. So that means, now that I've got that, I just literally need the formula so that the natural log of 1 plus I, complex natural log, is the natural log of the square root of 2. And you can do a few things with that if you want. plus I times pi over 4 plus 2 pi k. Remember, this is an infinitely valued function. Which is kind of a pain in the ass, in a way. That's a lot of shit gets spewed out into the complex world. So we're actually going to define a single valued version of it. So ln of x with a capital L. Now this might be different, Noah. I think this is different. That capital L, you never see that around.
No, it's too powerful.
It is too powerful. It is too mighty. For folks who haven't had the mental preparation for this. Jesus. Oh no! Okay. ln of z equals, so this is the principal PLE natural log. And this is defined to be just the natural log of the modulus of z plus I times the principal argument of z. And remember, this principal argument is betwixt negative pi. We can't get to negative pi, but we can get to the pi. So if you're in the top half of the plane, use a measurement between 0 and pi. If you're actually on the negative axis, negative real axis, you're going to say pi is the argument, and then negative stuff for underneath the world. So can you solve this for me? Find the principal solution. In other words, use this. E to the z equals -2. If you gave that to someone in calc, it would blow their mind. They couldn't do it.
Or they would just walk away, maybe. Maybe just walk away.
Go run water through this shirt. I'll be right back. It's too new. It's too new. It's just covered with spittle.
You can have whatever you want, Leah. It's your world. I'm just leaving it.
I can't tell you how nice this feels. Very comforting. At least it's not noticeable.
It's definitely a fashion choice.
It is a statement. Alright, so z is the natural log of -2. Principal natural log. So that is equal to the natural log of the modulus of -2, which will be 2, plus I times the what's the principal argument of -2? Pi. So, final answer, natural log of 2 plus pi I. Any questions on that at all? Confusion? Cool. I got another one here. I'm just going to put it on the take-home exam. That'll be a good one. Let's use this shit. let's figure out, and I did this a long time ago, what about complex powers? Yeah, awesome. I knew that's what you meant by ooh.
Yeah.
Ooh, awesome.
No, I've heard of these before. Like I did some of
Do you remember what this one was?
No.
-1.
It was e to the negative pi halves.
Wow.
Apparently we don't remember that, that's okay. Let's do it. Let's talk about how to do that. In other words, complex powers. So, we need a little, let me get this up here so I get it all right. So, suppose alpha is a complex number. Z is not 0. Then we're going to define z to the alpha. And this z is also a complex number. Z to the alpha is going to be defined as e to the alpha natural log of z. And so like this is a natural thing to do, and just think about this for a second. This is actually how you find the derivative formula for something besides e to a power in calc. But this, first what you do is you say, okay, well look, z is e to the natural log of z. So you just make this observation that these are inverse functions. And then you just raise both sides to the alpha. And then use power laws to just multiply those two together. So there's nothing mystical going on there, besides the fact that, you know, there's complex things happening. But this is it. We just use this. And this is the non-principal version. So again, there's infinitely many here. So we might want to specify that it's principal. Principal value, so that we don't have to do, because then we know once you have the principal value, just add on 2 pi's and you're good to go. Make life easy. So let's do I to the I. So I to the I. First thing I'm going to do, look at the rule here. This is e to the I, the power, times the natural log of the base. So that is equal to e to the I times, can you please just, what is the natural log of I? Let's do all the values, just to practice that. Find the natural log of I. Done, you should be coming up with an actual real value, just actually infinitely many real values, just different powers of e to a real number. But the first one, the principal one, is that negative pi over 2 power. principle though. It's just e to the negative pi over 2. Which is crazy. It just seems so wild that an imaginary thing, which is already like, what the hell's that, raised to an imaginary thing, is real. It just really blows all our ideas of what power actually means. Certainly, like mine, I have no idea how to like handle that emotionally, except to just tap into the raw joy and unknowing and not knowing that that produces. You all seem pretty tapped into that right now. It's very quiet in here. Everyone seems tired.
Yeah.
Let me make it through. Is this good? Does this make sense? Let's try it. One more. Please find. Ooh, this is a fun one. If you've got a calculator, you can give me an approximation to this. Yes, I know. We never get to get out the calculator. So if you have one, and if you have a phone, you have one.
I actually didn't have a calculator in my school.
You did? You have your calculator.
I know, but I forgot my like actual calculator somewhere.
There's a sweet scientific on there, though, right? Give me a decimal approximation if you can. You can give me the precise version. I want it in A plus BI form, please. What is the 1 over pi? Is actually, what is the pith root of I? Quite beautiful. Let's do the principle. Sorry, just do the principle value so that use a capital log there. We literally just found the natural log of I a little bit ago, so kind of just riding off of that. That was just pi over 2I. Write that up here just to make sure we're good on that. And if that needs explanation, let me know. Because it's really important to understand these things. These are our basic computations. But you can keep going on this. It's just e to the 1/2 I. Put it like that. And then you can use Euler's identity to take this down. You can get stuff we're not used to seeing, like weird cosine and sine values, but then we can put them in a calculator. And, get a feeling of substance to this this thing here. Ooh, I hear calculator buttons pushing. You don't have to be quiet. I like it. I like hearing them push.
Oh, my buttons don't make this noise.
It doesn't make noise? I don't know, I heard something, it was like, I don't know, Grace isn't, she's got like iPad, that's not good.
Oh, she's got a calculator right there.
Oh, is that it? Was it you that I heard punch in? Okay.
I just turned it on.
She aggressively turned it on.
Can somebody give me an what is cosine of a half in radians approximately?
0.8776.
Nice. And then that sine.
0.4794.
Did you say 47?
Yeah.
So let's put an approximate here. So look at that, we found I to the 1 over pi power. It's approximately that weird ass number. Yay. Now we just walk away and don't do stuff with it.
Cool.
Yeah, exactly. It is cool. Noah, what are you thinking about? You just thinking about it in
Just
general?
thinking about it,
Yeah, it's wild. So, we've got like 20 minutes left together. Why not like take this 20 minutes and start looking at those homework problems while we're together? Or not? I will stay here for the next 20 minutes if you want to work. If you don't, door.
No.
Sydney might want to go. But I'm gonna stay here. So like, I mean, I would stay and work,
I'm gonna get water.
but not even a bit of pressure. Do as you see fit. I will stay and work. Hi. Yay. I'm gonna bring a pen. Yes, ma'am. The principal value is just, so like if this, so like here's the plotted out. So that's modulus, right? The principal value is however
I'm gonna go sit
far,
here.
so the principal value is the argument, like the angle, but it's the angle that's between minus pi and pi.
I'm so sorry.
Actually, this way. Bye, Sydney, thank you for coming.
Oh, it's been a
Be
pleasure,
well.
Dr. T.
So it's just, instead of all the possible loop arounds, it's just like a single value that comes out. So, for example, when we had 1 plus I, the principal argument is just that pi over 4, and we don't have to add on plus 2 pi k. So it's just like a nice single value thing. Let's do another one. If this had been minus 1 minus I, then the argument, the principal argument, would be negative 3 pi over 4. Does that make sense? And then, like if I was on the real axis, like negative 2, and I think now I'm starting to think I actually did a problem wrong a little earlier. I think I did that I think when I did e to the z equals negative 2, I might have said the argument was pi over 2, didn't I? And that's wrong. Maybe that's why that was confusing.
No, it is pi.
It is pi. What did I say though? I feel like I said pi over 2 now in retrospect.
You did say, like, the between stuff, you said pi over 2, I think.
But I didn't write. I wrote pi.
Yeah, I said negative pi, and you also wrote pi, because I know I wrote
Okay, good. Okay, cool. Okay, cool. So like the arg, principal arg of negative 2, since it's on the real axis, is this guy. So that's pi. But everything underneath, like if I was like right there, that would be a negative almost close to negative pi right there. So it's just pi by, so it's really just the angle, you just make sure that you use a number between minus pi and pi to explain it, or to describe it. Does that make sense? Okay. So now knowing that, oh, I didn't do it right. Okay,
Yeah,
that's
you did.
nice. Okay.
So, when we find the principal, we just use the argument,
Yeah.
and this is the argument of,
That is an argument, and it's the principal argument, because it's so like for I, what's the principal argument of I? It's the angle, the simple angle, that's just like, I'm not spinning around a lot, it's just like how far from there to there, that's pi over 2. So that's the argument of I, the principal argument. But the full argument is pi over 2 plus multiples of 2 pi, right? So you got all those. So we just pick the simple one, that's
Okay.
between minus pi and pi.
okay, and then you take that and you work this. Well, property, but I kinda don't know where the number time.
So it canceled, the pi's canceled, because I had 1 over pi times pi over 2i. And so the pi's canceled, and that's just 1/2 I. So that just became, see how I've got them written up there? I've got the 1 over pi times pi over 2i. The pi's canceled, and so we just got 1/2 I. Does that make sense? It's okay, but you're less confused now?
Yes.
Okay,
We went on the IMs.
now that makes more sense, right?
Yes.
Okay. Yay.
Yay.
Cool. Thanks for asking the question. Yay. Yay.
I'll be right back.
Okay, you do as you see fit.
I'm gonna grab my computer from my house.
What are you gonna do?
My computer's at my house.
Oh, are you going to get it?
Yeah, I live like right there.
Oh, okay, that's right. Okay, that's cool. Yeah, we'll watch your stuff for you.
Thank you.
Well. You did good, Lou.